This tiny teach is going to be about glycolysis, the bridge between glycolysis and the Krebs cycle, and the Krebs cycle. Let's first start by looking at the equation for cellular respiration or aerobic energy production. It begins with glucose. We're going to slowly liberate the energy stored in the bonds of glucose by stripping the electrons and their energy using enzymes. We're going to pass some of that energy to electron carriers like NADH and FADH2, who will carry it to the electron transport chain, and those electrons will end up in oxygen and eventually water. But some of that energy will be used right away to phosphorylate ADP to produce ATP. Aerobic energy production includes glycolysis, Krebs, and the electron transport chain. As I mentioned, this particular tiny teach is going to focus on glycolysis and the Krebs cycle. I'm going to do another tiny teach and talk about the electron transport chain. Glucose feeds into the first step of aerobic energy production, glycolysis. Glycolysis literally means glyco for glucose, lysis for the splitting of sugar. Glycolysis takes place in the cytoplasm of prokaryotes and eukaryotes both. In glycolysis, we start with 6-carbon glucose, and that's going to be split into 2 3-carbon pyruvic acid. Sometimes you might have learned it as 3-carbon pyruvate. It's the same thing. Glycolysis has 10 steps. Each are catalyzed by a specific enzyme. We're not going to talk about the specific steps in this tiny teach. I'm just giving you a good overall idea of what happens in glycolysis. Overall in glycolysis, we're going to net 2 ATP molecules and 2 NADHs. So we're going to use some of the energy that we liberate by breaking glucose in half, and we're going to make 2 ATP molecules right away. We're going to take some of that energy and we're going to give it to the electron carrier NADH, and it's going to hang on to it and take it to the electron transport chain. Then in between glycolysis and the Krebs cycle, we have what I call the bridge. Some of you might have learned it as the preparatory step. So far, glycolysis has released that less than 25% of the energy that's stored in glucose, and most of that energy remains in the 2 pyruvic acid molecules. So we're going to use the Krebs cycle to try to liberate as much of the remaining energy as we can. The bridge is actually the bridge between glycolysis and Krebs. It takes place in the cytoplasm for both prokaryotes and eukaryotes. What we do is we take our 2 pyruvic acid molecules, and the carboxyl group is removed, and it's actually given off as a molecule of carbon dioxide. If we take a look at the cellular respiration equation again, carbon dioxide is actually on the product side of the cellular respiration equation. So at this point, this is where 2 of the CO2 molecules actually come from, this bridge step between glycolysis and the Krebs cycle. Electrons as we pull off that carboxyl group, the electrons and the energy that they're released are actually given to the electron carrier NADH. Since we lost a carbon, we now have a 2-carbon molecule called acetate. That's the product at this point, and we attach a coenzyme A molecule. So we actually have something called acetyl-CoA, and that's ready to actually enter the Krebs cycle. Since we had 2 pyruvic acid molecules, we have 2 acetyl-CoA molecules at the end of this bridge step. So now we're going to move on to the Krebs cycle. We have 2 acetyl-CoA molecules that are going to enter the Krebs cycle. It takes place in the cytoplasm for prokaryotes, in the mitochondrial matrix for eukaryotes. We do have 2 acetyl-CoA molecules that are going to enter the cycle. Each will, quote-unquote, spin the Krebs cycle 1 time. There's 8 steps in the Krebs cycle. Each step is catalyzed by an enzyme. I'm not going to talk about each step. I'm just going to give you a good overview here. The Krebs cycle is going to extract as much energy as we can out of the acetyl-CoA molecules and transfer that energy directly to ADP and phosphorylate it to produce ATP, or to electron carriers again, either NADH or FADH2. So at the end of the Krebs cycle, we're going to have produced 2 ATP molecules. We're going to have produced 2 FADH2, 6 NADH, and 4 CO2 molecules. So there's the other 4 CO2 molecules. So if we look at our overall cellular respiration equation, the 6 carbon molecules that started out in glucose are now here in the 6 carbon dioxide molecules. We basically broke glucose apart, and those 6 carbons from glucose are now here in carbon dioxide. 2 of them came off in the bridge step, and the other 4 came off here in the Krebs cycle. So as I mentioned, I'm going to talk about the electron transport chain in another Tiny Teach, and I'm also going to talk about other fuels that you can use instead of glucose. And I'm also going to have another Tiny Teach where I talk about the accounting of ATP as well.